have been discussing about binomial distribution. Last class we have seen the probability density function of binomial distribution. First of all, we have seen that binomial distribution is a discrete probability distribution. So, what is the definition of binomial distribution? We have seen that a random variable or a discrete random variable x is said to follow binomial distribution if its probability density function is p of x is equal to n c x p raised to x q raised to n minus x. See, we have seen this probability density function in our last class. So, a discrete random variable x is said to follow binomial distribution if its probability density function is p of x is equal to n c x p raised to x q raised to n minus x. Here what is n? N is the number of trials. N is the number of trials. What P and Q are two mutually exclusive and exhaustive cases, so that we have seen that P plus Q is equal to 1 or Q is equal to 1 minus P. P and Q are two mutually exclusive and exhaustive cases, so that sum of their probabilities will be 1. P plus Q is equal to 1 or Q is equal to 1 minus P. And what actually is P? P is the probability of success in a single trial. So P is the probability of success. P is the probability of success in a single trial. So if P is the probability of success, what will be Q? It will be the probability of failure. So a discrete random variable x is said to follow binomial distribution if its probability density function is p of x is equal to n c x, p raised to x, q raised to n minus x. So here n is the number of trials, p is probability of success in a single trial, and q is the probability of failure. And what is meant by p of x? P of x is the probability for x successes. So what will be p of 0? P of 0 is probability of getting 0 success. P of 1 is probability of getting 1 success. P of 2 will be probability of getting 2 successes and so on. That means here x can take values 0, 1, 2, 3, etc. So up to this we have seen in our last class. Today let us discuss some problems based on binomial distribution. So let us go to the first problem. See, the problem is 4 coins are tossed simultaneously. 4 coins are tossed simultaneously. Then what is the probability of getting 2 heads? So how will you solve this problem? See, 4 coins are tossed simultaneously. So here the number of coins is 4. If 4 coins are tossed simultaneously, what is the number of trials n? N is equal to 4. So here n is equal to 4. Number of trials n is equal to 4. You are required to find out the probability of getting how many heads? 2 heads. So probability of getting 2 heads is to be calculated. So here success is obtaining heads. Success is obtaining head. So what will be P? Success is defined as success is obtaining head. In this case, we have to take success as obtaining head. And what is P? P is the probability of success in a single trial. P is the probability of success in a single trial. So what is the probability of success when a coin is tossed? Here success means obtaining head. So what is the probability of getting head when a coin is tossed? Whether it is 1 by 2. And how will you calculate Q? Q is equal to 1 minus P, because P and Q are success and failure are mutually exclusive and exhaustive. Therefore P plus Q will be 1, or Q is equal to 1 minus P. 1 minus P means 1 minus 1 by 2, that is 1 by 2. So n is equal to 4, P is equal to 1 by 2, and Q is equal to 1 by 2. So we can find out the probability density function of binomial distribution by substituting the values of n, p and q. And we have seen that N and P are parameters of the distribution. Binomial distribution has two parameters which are N and P. So once you know the values of N and P, all the terms of the distribution can be calculated. So that is why these two are called the parameters. N and P are the parameters of binomial distribution that we have seen in our last class. So N is equal to 4. Success is obtaining head here. So here success is obtaining head. And what is P? P is the probability of success in a single trial. So what is the probability of obtaining head when a coin is tossed? It is 1 by 2. So what will be Q? Q is nothing but 1 minus P, that is 1 minus 1 by 2, that is 1 by 2. So what is the probability density function? P of x. P of x is NCx, P raised to x, Q raised to n minus x. Substituting the values, n is equal to 4. So 4C x, what is P? P is 1 by 2 raised to x, and Q is also 1 by 2 raised to n minus x, means n is equal to 4 minus x. So here the probability density function is P of x is equal to 4cx, 1 by 2 raised to x, 1 by 2 raised to 4 minus x. See, you are required to find out the probability of getting how many heads? 2 heads. So head is nothing but success. You are required to find out the probability of getting 2 heads. 2 heads means 2 successes. So what is the probability of getting 2 successes? P of x is probability of getting x success. So what will be P of 2? P of 2 is the probability of getting 2 success. So simply substitute x equal to, that is 4C2 into 1 by 2 raised to 2 into 1 by 2 raised to 4 minus 2. 4 minus 2 is nothing but 2. So what is the meaning of P of 2? P of 2 is the probability of getting 2 heads. So P of x is, what is the meaning of P of x? You must understand the meaning of P of x technically. P of x is the probability of getting x success. So what will be P of 2? P of 2 is the probability of getting 2 successes. That is probability of getting 2 heads. Obtaining head is defined as success here. So P of 2 is equal to 4C2, 1 by 2 raised to 2 into 1 by 2 raised to 2. So what is the meaning of 4C2? You know how to calculate 4C2. See, you can calculate it directly by using calculator. So 4C2 is, how will you calculate 4C2? 4 into 3 divided by 1 into 2. So 4 into 3, 12, 12 by 2 is 6. So 4C2 is equal to 6. 6 into 1 by 2 whole square is 1 square by 2 square, that is 1 by 4. 1 by 2 whole square here also is 1 square by 2 square, that is 1 by 4. So here we can calculate this. So we cancel this, divide this 6 and 4 by 2, we will get 3 and 2 respectively. So 3 into 1, 3 by 2 into 4 is 8. So 3 by 8 is the required probability. So what is the probability of getting 2 heads? Probability of getting 2 heads is nothing but P of 2, and that is 3 by 8. So how do you define a binomial distribution? So a discrete random variable x is said to follow binomial distribution if its probability density function is P of x is equal to NCx, P raised to x, Q raised to n minus x. Here n is the number of trials, P is the probability of success, and Q is the probability of failure. So that P plus Q will be 1 because P and Q are mutually exclusive and exhaustive. So what is the meaning of P of x? P of x is probability of getting x success. So here x can take values 0, 1, 2, 3, etc. P of 0 means probability of getting 0 success, and P of 1 means probability of getting 1 success, and P of 2 means probability of getting 2 success, and so on. So here in this problem, it is given that 4 coins are tossed and you are required to find out the probability of getting 2 heads. So since it is given that 4 coins are tossed, therefore number of trials is 4. You are required to find out the probability of getting 2 heads, therefore obtaining head is defined as success. So what is P? P is the probability of success in a single trial. Right. What is success here? Obtaining head is success. So P is the probability of obtaining head in a single toss of coin. So what is that? 1 by 2. Q will be 1 minus P, that is 1 minus 1 by 2, that is 1 by 2. What is the probability density function? P of x is NCx, P raised to x, Q raised to n minus x. That is P of x is equal to 4cx, 1 by 2 raised to x into 1 by 2 raised to 4 minus x. So P of 2 is probability of getting 2 success, and that is 4c2 1 by 2 whole square into 1 by 2 whole square. Simplifying this, you will get 3 by 8. So what is the probability of getting 2 heads? It is 3 by 8. I think it is enough for today, and I will give you the detailed notes about this in PDF format. You just take down the notes, and if you have any doubt, you can ask it to me. Okay, in our next class we will discuss some more problems based on binomial distributions. Till then, bye.